In the annals of military engineering, few machines are as absurd or terrifying as the Schwerer Gustav. This colossal railgun was the pinnacle of Nazi Germany's obsession with gargantuan weaponry. The scale of the gun was truly astronomical. It weighed a staggering 1,350 tons and stood as tall as a four-story building, dwarfing every artillery piece that came before it. Developed by Krupp in the late 1930s, the Gustav was designed to shatter the impenetrable fortifications of the French Maginot Line. It was a weapon born from the desperation of trench warfare tactics. To move this beast, engineers had to construct a double-track railway system. It was not a weapon that could be deployed on a whim, but a literal moving fortress on rails. The barrel alone was over 30 meters long, capable of firing massive shells weighing 7 tons each. These projectiles were designed to penetrate concrete bunkers and deep underground munitions stores. Operating the Gustav was an organizational nightmare that required over 2,000 men to assemble and fire. It took days, sometimes weeks, to set up the tracks and position the weapon. Because of its immense weight, the gun exerted immense pressure on the ground, requiring specialized ballast and reinforced sleepers. Any terrain shift could render the firing solution completely inaccurate. When the Gustav finally saw action, it wasn't against the Maginot Line, but during the siege of Sevastopol in 1942. The Germans aimed to crush Soviet defenses in the Crimea. The shells were so heavy that a specialized crane system was mandatory for loading. The process of loading the gun was agonizingly slow, limiting its rate of fire significantly. The sound of the firing was legendary, described as a thunderclap that could be heard for miles. Observers claimed the sheer vibration shattered nearby windows and rattled the teeth of soldiers. Despite its power, the Gustav was ultimately a tactical failure. Its slow setup time and vulnerability to air attacks made it a logistical liability for the German Wehrmacht. The impact of a single Gustav shell was devastating, pulverizing reinforced concrete structures with ease. It turned deep underground command centers into instant graves for the soldiers inside. Allied aircraft posed a constant threat to the gun, forcing the Germans to camouflage the weapon heavily. Netting and fake foliage were used to hide the giant steel monstrosity from above. The Gustav was also incredibly expensive to maintain. The wear and tear on the rifling of the barrel meant it had to be replaced after only a few dozen shots. As the war turned against Germany, the railgun was relegated to a propaganda tool. It represented Hitler's belief in wonder weapons that would eventually save the crumbling Third Reich. By 1945, the Nazi leadership realized the futility of their heavy artillery programs. The Gustav was ultimately dismantled to prevent its capture by the encroaching Allied armies. Later in the war, the Gustav was transported toward Leningrad, but never fired a shot in anger there. It was eventually withdrawn as Soviet forces advanced and threatened to capture it. The remnants were discovered by American troops in the Bavarian woods. They found only parts of the gun, as the retreating Germans had destroyed the critical firing components. Looking back, the Schwerer Gustav serves as a cautionary tale about the dangers of over-engineering. It was a project that consumed vast resources better spent on more practical weaponry. The gun's sheer size was its undoing. While impressive on paper, it lacked the mobility and flexibility required to influence the fast-paced, fluid nature of World War II combat. There were two guns produced, the Gustav and the Dora. Both suffered from the same issues and were ultimately relegated to secondary roles as the war reached its peak. Engineers from Krupp had hoped to develop an even larger version, dubbed the Landkreuzer P-1500 Monster. Thankfully, this design never left the drafting board stage. The Schwerer Gustav reminds us that technology, when divorced from reality, becomes little more than a vanity project. It was a weapon of pure intimidation that failed to win the war. Today, nothing remains of the original guns except for some loose shells and structural debris. The legend, however, lives on in military history forums and documentaries alike. In hindsight, the resources sunk into the Gustav could have produced thousands of Tiger tanks or aircraft. It is a classic example of the Hitler trap of vanity war manufacturing. Even the logistics of ammunition supply were a massive hurdle. Each shell had to be transported by specialized railway cars, further complicating the supply lines of the Wehrmacht. Despite the frustration of its deployment, the accuracy of the Gustav was surprisingly high. At long ranges, it could land shells within a small radius of the intended target. The gun crew required constant protection from ground infantry and air cover. A single successful bombing raid could have destroyed the entire rail network around the weapon. This accuracy, however, was negated by the time required to calculate new firing coordinates. By the time the gun was re-aimed, the battlefield situation had often shifted entirely. The psychological impact on the defenders was arguably its most successful feature. Being targeted by a shell of that size instilled genuine terror in enemy troops on the ground. Yet, terror alone does not win wars. The Gustav failed to break the morale of the Soviets or change the strategic outcome of the Eastern Front in any meaningful way. The sheer weight of the ammunition also necessitated specialized internal ammunition elevators. These complex hydraulic systems were prone to freezing in the harsh Russian winter temperatures. Maintenance crews were always working under immense pressure. One broken gear could disable the entire firing sequence, leading to long delays and logistical bottlenecks at the front line. Many ask if such a weapon could be built today. With modern precision-guided munitions, the massive, inaccurate railgun has become entirely obsolete in modern military doctrine. The Gustav really captures the imagination of anyone interested in WW2 engineering. It remains the largest caliber rifled weapon ever used in combat in the history of warfare. Yet, there is something undeniably fascinating about the bigger is better mindset of the 1940s. It represents a different era of warfare that seems alien to our current technology. The legacy of the Gustav is preserved in countless model kits and digital games. It has become a staple of pop culture when discussing the weirdest weapons of the conflict. The railgun era was short-lived, pushed out by the development of long-range heavy bombers. Air power rendered the slow, land-bound artillery pieces largely redundant on the battlefield. As we look back, we should remember the men who built it and the men who faced it. It stands as a testament to the extremes of human creativity and destruction. Still, the engineering challenges overcome by Krupp in the 1940s remain impressive. They pushed the boundaries of metallurgy and structural physics to an unprecedented degree for the time. Even after the guns were scrapped, their components were studied by Allied engineers. They were looking for any secrets in the design that might aid their own artillery development. Each firing of the Gustav required a precise wind calculation to ensure the shell hit the mark. Meteorologists were part of the firing crew to predict ballistics trajectories. Today, we can look at the Gustav as a monument to how far technology can go astray. Its story provides a lesson on the necessity of practical military planning. The Gustav was not just a gun, it was a symbol of power. Its deployment was often accompanied by photography sessions to convince the German public of their superiority. We hope this deep dive into the Schwerer Gustav has provided you with a unique perspective on history. It is a topic that never ceases to fascinate us. Make sure to subscribe to the channel for more deep dives into the forgotten corners of military history. We have plenty more stories to tell about these machines.